Well, hi, good morning. Thank you for joining me in my shop here. It's September 6th, last of our super hot days. Actually, I shouldn't really call them super hot. There's nothing out of the ordinary happening here weather-wise. It's just hot. 30, 31 with high humidity. That's within the range of normal here in the summer. Okay, so all that's really left to do on this radio is the final alignment steps, which involve the RF circuits in the radio. And I'm going to read them over again. I've read them a couple of times. I'm going to read them over again before I start. And we'll hopefully peak this radio up, peak its performance up. I'm just looking at the pointer on it right now. Make sure it's quite level. The thing about this pointer on this radio is it's a little bit curved. It's got a bit of a smiley thing happening here. So it's not really pointing exactly where this is set because it's curved. I think I'm going to ignore that for the most part. This is not a precision receiver by any means, so you just need to get in the ballpark and then hunt down your station, and it's quite capable of doing that right now. So okay, so I'm going to get set up for the first step in doing the RF alignment here. Okay, before we get going here, a couple of things that are a little unusual. This trimmer capacitor here. Now that I've looked at it a little bit more closely, this trimmer capacitor is simply in parallel with this one. So what's happened is there isn't enough capacity in this small trimmer to do the job, so they've added another trimmer, and so it's a combination of these. They're just in parallel. But there's something more about this capacitor. You can see my camera here. We're going to look through that camera now at the plates here. Now this is a little bit subtle. I mean, if you are into this, you know what I'm going to be talking about already. I'm just getting a stick here. And that is, in a lot of these radios, the plates are used as a rough alignment in the factory. And what they do is they reduce the capacitance of the capacitor, the tuning capacitor, by bending these outside plates away. So now, a lot of radios it's not done at all, but in some it is. And if you look down where I'm trying to point, if you look at this plate here, you see I can stick my stick on it. It's sticking out a little bit. It's been bent out. And you see how the plates are split. You can really see it quite clearly down here, the split. That's to allow individual sections to be moved separately. So you could really work this capacitor to get exactly the kind of, I hate to use the word linearity, it's nothing linear about it, but to get the right alignment basically, or rate of change of the capacitor. I don't know how to put it exactly. You see the plates here are bent out a little bit, and this one appears to be bent out just a tiny amount. Down here, I already showed this one seems to be bent out. So another thing that happens to these capacitors is people reach inside these radios for one reason or another. They get their hands on these plates and they push them in by accident. So occasionally you'll find one of these radios, the plates are actually rubbing from that kind of thing happening. Somebody clumsily jamming them together. But when they're bent out, it's almost certain it was done very carefully in a lab, factory sort of situation with someone who knew what they were doing very carefully. So not to change those. Now, in a lot of radios, I have found that the trimmer up here just isn't enough to do the job. I find myself opening these all the way open and never really getting a strong peak. And, not too sure what to do about that. Well, maybe I could. If I found that condition, I could choose to bend these outside plates outward and reduce the capacitance of the main capacitor. Try to bring it within the range of the trimmer, or in this case, trimmers. I've never done it. I've shied away from it. I probably shouldn't shy away from that at all. Okay, we're ready to do the alignment here. when it comes to setting the local oscillator, rather than follow the instructions, I'm going to avail myself of a better opportunity. I believe it's a much better way of doing it. Couldn't be done back in the day because people didn't have SDR radios, fantastic radios. That's not doing anything. I'm just setting it there. I need to get a couple of things here, and we'll get ready to check the local oscillator frequency against the setting on the dial. Okay, in the top right is the SDR frequency display, and I'm using this loop to pick up signals. That's not very impressive. There we go. Making sure everything's working. Okay, so where would I put this? Put this somewhere where the local oscillator is bound to be strong. And since the radio is upright, right near the capacitor here should do the trick. So I just want it in a stable spot. It's not going to move around. Just throw it in. That's probably going to do the trick, just like that. Just make sure that this isn't touching. I think we can take the camera out of here. That's not going to help. Oops. Okay. That's going to sit there. These wires are not short. Yes, they are. They are shorting. Not the best arrangement. Okay. We need to switch on the radio. And watch what happens on the SDR. Let me just stick a little piece of paper here to increase the flammability of the radio. There. Okay, everybody stay put. How about I just freeze this with a clip? Okay. We'll turn on the radio and we can watch the SDR display, and we should see a large signal rise up. And I'm going to set this very purposefully. If I set it at 1 million on the dial here, then we should see it rise up around 1,000,456 was the supposed spot. Now, of course, I don't know the radio is really tuned to 1 million. I'm just going by the warped pointer here. But, well, it is tuned. I guess you gotta say it is tuned to 1 million. Let's see what the electronics have to say about that. So I put this red line, might be hard to see, right here, and that's marking where the local oscillator should rise up. Rise up. Okay, let's give it a go here. Away we go. Watch and see. Here it comes. Well, wow. Okay, so you see all those noise signals. It's on the same level as the noise signals. And it just picked up by the coil where it's sitting. It's not the strongest signal there, but we can work with it. The actual frequency here is 448. Okay. Let's put it back to 456. Now, how accurate is this tuned? So, if I go by the pointer, actually, I think this would be more like 1 million here. I've just barely moved it. Where is it now? Where'd it go? Is it right on? Is it right on the thing? Let me just make it move a bit. Oh yeah, there it is. Right on. It's right on the money. Well, there's nothing here to adjust. In terms of the local oscillator, it's right where it should be. Let's try another location. We're kind of in the middle of the band at 1 million. I'll go down here. I'll set this to, how about 550. So that's 550. So 550 plus 456 sounds like 1,000,001. Would that be right? 450 and 5. Yeah. Okay. And where is it on the chart here? It's right here. There, 1,000,000, and so it's dead on. It's really, really good. Let's go up here. This could be because of the plate bending that was done on the capacitor. Whoever did it got it right on. I'm going to set this now to 150. 1,500 really. Okay, 1,500. So 1,500, add another 450, 1956. Hey, that's a really good year. 1956. Let's take a look here. 1948. That's not so good a year. 1956. So how close am I tuned here on the radio? We could go just a touch higher like that. It's, yeah, and where should it be? Let's just take this up to 56. It's a tiny amount off. Now, I'm going to tune the radio. I'm going to put the local oscillator rate to where it should be. Okay, now that's the proper frequency there. Just running it over my head. 450. Sure. Now look on the dial here. How far out is it? Well, the fact is, because this is curved, if you just extend the straight part out, it runs right across 1,500. The curve is throwing it off a bit, so it's dead on again. Well, wow, that's fantastic. There's no need to adjust any of that. Okay, what is there a need to adjust then? Local oscillator's okay. There's an adjustment coming that's up underneath the chassis. We're going to have to get at that. Unfortunately, I've got the radio this way. Okay, and what I'm going to do is I'm going to go and drink some coffee, and then we'll do the next step. Well, if you read the instructions here, there's something quite interesting. D, set loop switch to loop position. E, adjust this stuff. F, set loop switch to loop position. What? Wait a minute. I did that up here. So it's very unusual for these instructions to have something illogical in them. They're not complicated instructions. But here, it's set loop switch to loop position. Set loop switch to loop position. And you know what? They never actually suggest you move the signal generator from the direct wire connection anywhere in here. Could be on purpose, or I don't know. So what I've done though is I've set up a transmitting loop near right on the antenna, or almost in contact with the antenna, and I'm going to transmit the signal generator into the loop antenna on the back of the radio, and we'll make these two adjustments. One is adjust the oscillator rear section of gang condenser. Okay, that was the oscillator adjustment, which I've done. Set loop switch to loop, and here we go. Okay, set loop switch to loop. The loop switch is back here. Okay, set the loop. I have the signal generator running at 1400 kilohertz, and it's feeding this loop here, which I'm just going to hang like this. Something like this. Hang it like this. There we go. This is set very low. I'm going to crank that up a little bit. And now I can turn the radio on. Oh, I haven't had it on. Okay, radio on. And we're going to want to pay attention to this meter at this point. Probably shouldn't have it standing up, but I think if I put it like this, you're just going to get a washout. So I'm going to leave it like that. It isn't the value anyway, it's the movement up and down. We'll set this to, let's say, 10 volts to start. Tune the radio a little bit and see what happens. Yeah, it's definitely working. So this is reading the AVC voltage. We'll tune the radio to 1400, making absolutely sure. So what they've done here on the dial is some of these dots are square and some of them are round. At a glance, you can't tell. If you look closely, that's square. So square lines up, and the dot is the halfway point. So, yeah, this is the end of it right here. Actually, you can't go from 1500 to 55. So if we're looking for 1400, it's going to be a square. Not going to be that one. $900 million, million 10, 12, 13, 14. It's got to be this one. And the next one's 15. It's got to be that one. So let me just line it up here. Once again, I'm kind of pretending the pointer is straight. So I'd say that's 1400 there. You can always, this doesn't have to be done exactly on 1400. This has to be, the radio has to be tuned very accurately. So we'll find out what, well, first of all, is this coming in? Hello? Hello? Nope. How about like that? Should be coming in right here. Hello, hello. Something very weak about this. Okay, something very weak about that. I think because, well, it's surprisingly weak. That I would have expected that to be just clear as a bell. Let's move the antenna around a little bit. A little better if I get it down here. Still, that's my maximum output here. And you barely hear it. All that hiss. Okay, let's watch the AVC. I'm going to tune the radio right on the money here. It was right on the money. Okay, can we get that to go up higher by making these adjustments? If we're going to use a metal screwdriver on this sort of first hand effect, doesn't move the meter. Good. There we go. Down. Okay, there's a clear peak right here. Okay, and then the other one is right on that antenna. It's over here. Okay. Cool. So I'm tightening this right down. Now this is right down. Let's back it off. It's actually peaking right here. Okay, that's a little bit of an improvement. Let me try the one underneath again. Here. Just move the camera. Otherwise my arm's going to be in front, or was it in front before? But this shouldn't be any different. Okay, here we go. That's it. Okay, this is it. So the radio now is basically in its top performance condition. Sort of. I'm not sure what I meant by that. Not a lot more I can do to this radio to make it perform better. We still have this big capacitor sitting here. which I think is having no bearing, but could be wrong about that. So I want to lay this down. Turn the power off while I do that. Okay, power back on. We're going to give it a shot. Tune around, see what we can get. So all the way from here down to about here, there's really no stations to pick up. During the day, down in my shop. See, the hiss is getting quieter and quieter. Compensate with the volume. Listen to that. What happened? She just went away. She's gone away. Well, that's not very good. So the last alignment steps were done up at this frequency. A lot of strange sounds here. Managed to kill it off down here. So, contrary to the instructions, since this is where the stations are, down in this part, I'm going to set this, get this little noise signal there, I can barely hear it, and I'm going to adjust those, the antenna trimmer again. What's that terrible buzz there? Okay, that did nothing. Capacitors shouldn't be terribly effective at the lower end. What have I done here? I've gone from the radio working okay to these connections coming out here. I'm getting nothing on the meter. Even the meter shows the difference. She's gone away, Jim. Okay, let's tip it up again. We have an unexpected result here. Okay, power back on. No, I didn't have it on full power, but I don't think that's going to make any difference. Or did I? What's with that buzz? So the buzz is probably just coming from this clip lead. Okay, we don't really need this hooked up. Ooh. Yeah, let's take this off. We'll leave the ground on. I don't think it's going to do anything. Just shorten it there. Okay, I'm going to try adjusting this capacitor. Again, it was tuned at the upper end, and we're down at the lower end. No difference. Upper end. I've knocked the alignment out now. Oh. No effect at the lower end. How's this radio go from working okay to not working? You can bring it in my shop, that's how. I didn't adjust the local oscillator at all. I just adjusted these two trimmers now. Come on, this can't. Did I flip the switch off the loop? Oh, it's what I've done. It's what I've done. Now it's on the loop. Oh. Okay. Okay, coffee. Yeah, that was a dumb mistake on my part. Okay, got to redo a couple of things here, but coffee first. Okay, let's see how this works. Now the loop antenna is engaged. I've got the transmitting loop sitting here again. Generator still at full power. That's more like it. It still has a funny sound to it. It has like an engine is running in it. Could be some kind of interference here. Don't know what that sound is. Okay, I'm going to ignore it for now. So we're going to tune this. We'll do this at 1400. We tune the radio right on. What am I doing? Not doing the oscillator, Jim. I'm doing the RF. So we just need to tune this until this is maxed out here. Okay. Adjust these. Oh my gosh, it's not doing a thing. How can that be? Too much signal. Wondering what I'm doing there. Some audio cables, maybe in your stereo, if you take the cable and strike it with a metal screwdriver, you'll hear that come out the speaker, just hitting the wire. Some wires. Don't know what that sound is. Let's not get too sidetracked here. How come this didn't do a thing? That's right, I was lowering this. You're really supposed to do this with a very low input signal anyway. This guy, so right. The instructions never tell you to put a loop on like this. So I'm going to follow the instructions here. This onto the B- ground and put this back on. Right. Seems kind of odd. Now I'm going to flip the switch and make sure I've got this working here. Okay, so we're tuned. Switch back to the loop. More power. Now, I adjust this. What happens? What has happened here? Looks like this is peaking this connection here, and the other trimmer is obviously peaking the loop, and they don't have anything to do with each other. That's the impression I got. Okay, so we're going to get off this, switch back to the loop. Let me try a better transmitting loop. This one's got more turns. Okay. Wire. Loop. And now the loop trimmer. Make sure things are tuned first. Watching this. We're right near some other signal. Okay. Okay, this time the capacitor is not closed all the way. It's in the middle of its range where it should be. Okay, radio, let's try it now. Well, that's better. Okay, now I'm going to try and tune that antenna, listening to the station. You can still watch this. Very little effect. And that's to be expected at the low end of the band. That's not bad. Let's disconnect this interfering. Nope. $590. You heard him say it. Let's see, it's pointing right at 590. The fan, 590. Good morning. Okay, let me set this radio down and we'll take this out. So it's just its normal self, all by its normal self. There we are. Okay, power back on. So I think that's 710. Okay, 840. That's a round dot. What's going on here? Square, 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 square. A round dot. Where's 8? What have they done here? No, I can't pick it up, but I have a little trick I'm going to try, which may or may not work. Most of my tricks don't work. So I'm not the best magician, but I'm going to give it a try. We'll see if we can get a little more excitement out of this radio. French station. How am I doing that? So, you see this cable hooked up to the wire input. Selector's on the wire. And this wire is heading to this antenna. So I guess that's to say that big loop back there works a lot better than this little loop here. And is there any surprise in that? I have compared that big loop antenna to other commercial, a particular commercial loop antenna about this size. It's about the same size as this. And that big one beats it, for sure. So size matters. There we go. I think I'm done on this radio. I don't think there's much more to get out of it. If I were to take this outside, away from my shop, you know, above ground and all that kind of stuff, this would work quite well. This would be quite a good performer, even though it doesn't seem that way here in my shop. You'll have to trust me on that. So thanks a lot for watching this series. I declare it over. What I still have is not only this cabinet, I have 2 other radios I recently worked on. All of them have similar wooden cabinets. They all need work. And I'm not a cabinet guy, but I will do something with them. Spruce them up. I guess maybe that's the word for it. I will spruce them up with minimal effort. Try to get the maximum benefit from minimum effort. Okay, well thanks a lot for watching, and something else will be in here tomorrow. Don't know what. See ya.